Okay, all right. So I believe you can all see my screen, and you see this. We have got an employee application that we started with. We just created a product class also, but we did not do anything much in that. And in the employee class, so can I create few more constructors or not? What if I wanted to create a constructor like this? I say public. Now I say public employee, and I wanted to create an object which just simply to start with an ID. That's it. I'll say this dot ID is equal to ID. That's okay, fine, no problem. So the new object will be created if I use this constructor. A new object will be created with the default value of ID, but then or whatever the value of ID I want to set at the time of creating the object, but then otherwise name and address will still be null, and I can very well use the setter methods in order to change the value of name, in order to set the value of name and address. So like the way we created setter methods, similarly there are getter methods as well. So you see this, I can say public void. So what if I want to get the value here? I want to get the value out of the class. So this is the class employee class that I have. Employee app is another class, and if I say emp3.id, I don't have that option. I cannot say ID, or I cannot just simply say as out and print me the value of ID. It won't. Why? Because ID is again the same stuff, right? It is private. ID has a private access. So I go back here and I can very well, now this time I'll say public. I won't say void because it is supposed to return some value. It is just that instead of set, I will use get. And I'll say what is the data type being returned back? I'll say int. I'll say get ID. And in brackets, I will say, of course, nothing in brackets, nothing in parameters. You must never ever have any parameter in the getter method. And I will say return this dot ID. You see, here I did not write any return method. You might have seen no return. Why? Because it is void. Isn't it? That's void. I cannot return a value. I don't want to return a value, but here I do want to return a value because in the signature of the function I have mentioned that it will return an int. Similarly for string, for name and for address also, it will return string for name as well as address respectively. So again, instead of typing it out and instead of manually writing the getter methods, I can always click right mouse button. I can say generate. I'll say setter and getter both, or I can just simply say getter, and then you see this name and address. I can select both of these. I can press shift and I can select both, and I click on OK. You see this get name and get address is created. You can see this. If you want now once and for all, I'm going to remove everything. I mean everything in the sense all the setter getter methods. Please see, I have removed all the setter getter methods, and now this time when I click right mouse button and I say generate, I will say I want to generate both, setter as well as getter. See, right mouse button, generate, and I'll say getter and setter both. So you see it gives me the list of all, and I say shift and I say ID, name and address all. I click on OK, and you see this, it generates get ID, set ID, get name and set name, and get address and set address. Isn't it? I just simply save this, I go back here, and then you see in order to get the value, I'll say get ID. In order to get the address, I'll say emp3.get address. Now the point here is that, what are we doing here? So we have created private variables. I repeat, we have created private variables and we have created public setter getter methods. That means we have prevented the direct access to these instance variables, and we provide access only and only through the setter getter methods. You see the setter getter methods here. We provide access only and only through these setter getter methods. Why? So that we encapsulate. I repeat, we encapsulate. You see this here, I'm writing encapsulating. I'm saying I'm encapsulating the state of the object and provide setter getters in order to access the state, in order to allow access to the state from out of the class, right? This is what we have done, correct? This is how it is. So encapsulating the state of an object, so the state of an object will not be accessible from out of the class, and provide setters and getters. I will provide setters and getters in order to, I'll say and getters, in order to allow access to the state from out of the class, in order to allow access to the state from out of the class. So that's exactly what we have done. So this is called, this is very in its simplest form, this is what encapsulation is: encapsulating the state of an object, right? So encapsulating the state of an object. So this is how it is. Now come on friends, I want you to create getter methods as well. At least one of those methods you do it, you type out manually, and then the other methods you can very well generate using your IDE. But I want you to at least type out one single method, any one of those getter methods manually. You type it out. Okay friends, come on, get started. Yes, Manisha, we have to return this, so this dot name. So we've got to say return this, return name. Okay, even if you do not give this, it automatically understands that name is referring to the variable of the current object. So even if you do not give, it's fine. This dot name, this is absolutely fine. This will refer to the current instance. If you give, it's okay. If you don't give, fine, no problem. Right? If you give, it's okay. If you don't give also, it will work. Right? Get ID, you can say this, that. It's fun and the same stuff. Come on friends, get started. I will, yeah. Yeah, tell me, Anikendu, tell me. You have a question? Okay, sir, if we keep on redefining the same construct, will it keep on overriding the previous construct? Construct means constructor. Will it keep on overriding? No, why would it override or anything? You are overloading. Overloading means what? You overload. You have got one function, you are overloading it with additional behavior in the second constructor, and then you can have other constructors as well. So all the three constructors will be there. You can use any one of them, right? You can use. Right, so any class that you do not inherit from anything else, if you have not given anything here, like public class employee, you did not say extends from anything, it eventually gets extended from the object class. So even if you do not mention here, it extends from the object class, right? I go to the terminal. You remember we do have pwc-training. Okay, and you see this, we've got demo class there. I'll say java p-c and I say demo, and you can see this here. You've got the constructor, the default constructor over here. You've got the default constructor, and you see public class demo. Okay, and you can see this here, method java.lang object.init. What does this mean? It is creating a new object of class demo, and you see java.lang.object. So the constructor of the object is executed. What does this mean? That the constructor of the superclass is getting executed. So you see this here, employee, even if you do not give anything here, it is as good as saying extends object. Even if you do not give, it is as good as. So you don't need to. It implicitly extends from object. I repeat, it implicitly extends from object. Suppose you inherit from something else, like in our case, in our earlier case, we said export customer, it extends from customer, fine. So you say that this export customer does not extend from object? No, it does extend from object. I repeat, export customer also extends from object. But how? Export customer extends from customer, but customer in turn extends from object. So eventually, note my words, what I'm saying, it's pretty simple. It's very, very simple to understand. See the statement that I'm going to make. Each and every class in Java is a type of object. I'm sorry about that. I'm sorry. Yes, the object class. Okay. You may be thinking, what is this now, Shakir? You said class is a class, that's a blueprint, but then you have objects of a class, right? They are two different things. Class is one class that you create a number of objects of it, and this was all good up till now, and now you are telling us that each and every class is a type of an object. Well, as far as the library is concerned of Java, listen to me very carefully. As far as the design of Java library is concerned, the code is concerned, the way they have structured the classes, the way they have named their classes, this statement holds true. But otherwise, a class is a class. It is not an object. You create an object of a class. But you know what? They wanted to provide some default behavior to any class that you create in Java. I repeat, they wanted to provide some default behavior. Once again, I will repeat, they wanted to provide some default behavior to any damn class that you create in Java. So they said, why not have a class that will be the supermost class? And even if you do not inherit a class from something else, it says we are going to implicitly make that class inherit in the bytecode. When you compile the class, we are going to implicitly inherit that class from that one super class, and this will be the mother of all classes, and this will be right in the top, and you will have all the classes inheriting from this, so that some general functionality, I repeat, some general functionality that we want to provide to. Now, who is saying this? We means we, who? The authors of Java, right? They say that if we wanted to provide some generic behavior, some default behavior to any class that you create in Java, so that the object of that class will have some default behavior, some generic behavior, then we need to create that super class. It just so happened that they named that class as object. I repeat, it's just so happened, right? And I will not go back and question them. I will not say, hey, yeah, well, I mean, what idiots are these people? They are saying a class is an object. I mean, they have created a class called object, right? See this. I won't do that. Why? Because there's the reason. You see this? There is a class called object in Java. And you see, class object is the root of the class hierarchy. Every class has object as a superclass. Correct? All objects include arrays, everything, all objects, including arrays, implement the methods of this class. Correct? Now, why wouldn't I question them? For a simple reason. I accept the fact, and it's a fact, that they are smarter than me. Right? So I will be the biggest fool on this earth to question them. If they have done something, they are right. They are PhD guys, they are smart guys, they are PhD in algorithms, they are PhD in languages. Correct? I will accept the limitation of my knowledge and my understanding, rather than going back and saying, hey, you shouldn't have given the name of the class. I've seen some people, they argue, why did they do this? Okay, maybe there is a limitation of our understanding and you don't understand, but do not try to question them then why they should have done this. Or no, they are correct. Maybe we are not getting it why they have done that today as of now. You can, maybe down the line you understand, but here this is no one does a debate or an argument on this. It's an accepted fact that the supermost class, they named that class as object. Correct? So even if you do not extend a class from anything, it's by default extended from object. And that is the reason. So if I have a class that is extending from something else, don't you think all the features of that class will be available in the subclass? Yes. So you see this now. If I go to any one of the functions, just because I want to write some code, I'm going to some function. I cannot just simply start writing code here unless I define variables. I can define variables, out of the functions. I can define variables like these here, but then otherwise, if I want to write some code, I'll go to the function and start writing code. So suppose this is the function, I'll say super dot. Can you see this? The moment I say super dot, so what is super? Super is the keyword that is used in order to refer to the features, the functionality of the superclass. And all of these clone, equals, hash code, toString, get class, finalize, notify all, wait, and all of this. All of these functions right from clone to wait, all of these functions are there actually in the superclass. And which is the superclass? Which superclass is the class? Object class. See this here. Now when I say command O, or if I say control O on Windows, these are the same functions that I showed you there in the employee using super dot. Dekh lo apne aap khud dekh lo, you yourself can take a look at it. And quite a few functions. I mean, in fact, many of these functions here. For example, clone is the function. Take a look. It's a native function. The functionality is not implemented in Java, rather it is implemented in native code, C language, and that code is there on your machine, either in the on your machine it is in DLL files, and on my machine it is in dylib file, which we have discussed yesterday, isn't it? Platform specific. And then again you see this here, I've got finalize. Take a look at this finalize. It's just an empty method. You can override this. Then there is equals here. You see this equals, return this is equal to object. This is the default. This is the default. So it compares references. You can see this. It compares references. You can. I will come to this exactly. That's one of the major objective of discussing all of this. I'll come to that. But then otherwise, you see this notify. It's a native method. It has got something to do with threads. Don't worry about it. Beyond the scope as of now. So I'll say, you see this. You've got notify all. That is also native. Right, you say registered natives. This is exactly where all of those library files are registered. Right, this is exactly where the files are registered. I mean those dynamic library linked files are registered. Then you have toString function. Can you see this toString function? So this is how it converts to string. Right, so what it does is that earlier you remember I had said that is the memory address when you print the now let me so you see this. I'll explain this once again. ToString, you remember what is this ToString? This ToString is the function which converts an object to a string. It gives me the string the representation of the string representation of the object, right, in the string format. Correct, that's what it does. So you see, these are the functions. Now I would like to again go back over here, and I would like to show you these two significant functions which you are going to come across, and you will be working with this in your projects a lot. Two functions out of all of these. One is the toString function, this toString function, and the other is the equals function. You can see this equals function. Can you see this, friends? Right, so we are on to some very, very interesting topic and very critical. You don't understand it, then there is a problem. If you don't understand this, there is a problem. You're getting it? These are the two things that we are going to discuss, right? Equals and toString. Okay, so let's start with this. So do you have any questions on this point that super keyword refers to the parent class? Not the parent class objects. Hello. Not the parent class object. It refers to the method that is declared in the parent class. Okay. Whenever you have got a class inheriting from another class, and if you create an object of the subclass, please don't think that the object of the superclass is also created. No, never. Okay, never. The object of the subclass is created unless you explicitly create the object of the subclass, the superclass, and that too, if that superclass is non-abstract, you will be able to create an object of it. Otherwise, got it? Also variable and constructor. I didn't get your point. What do you mean by also variable and constructor? I mean, this is the continuation of what? Also variable and maybe you're trying to say something. Okay, no problem. But then this is how it is, right? So constructor will be executed. Always the constructor is executed of the entire hierarchy. It doesn't mean that it keeps on creating the objects of all the superclasses. Yes, super keyword. So if you say super and open and close bracket, it will refer to the constructor of the superclass. If you use super and open and close bracket but pass some parameters, it will refer to the constructor based on the parameters that you have passed. So super always refers to the parent class, not the object of the parent class, the parent class, right? Super does object class gets loaded whenever any other class is loaded by Jim. Yes, of course. Yes, 101%. It's a very good question, Rakesh. Impossible otherwise, right? How would it otherwise know? So the entire hierarchy will be loaded, but will it keep on loading every now and then? Say for example, object is the class. Will it keep on loading the object class every now and then? No. So when it sees that yeah, correct, perfect. So you've got class A inheriting from object, class B inheriting from object. It sees that the class A is inherited from object will be loaded. It sees class B is also inherited from the object. It will not reload the object class. It's already there. It will load it. Do we pass the object from method? I didn't get you. Do we pass the object from method? We can always pass objects, right? So I mean, we can always pass parameters to methods, and those parameters can be object of any class, right? But I'm not getting your point exactly. Do we pass the object from the method? I didn't get you. We can pass class also in the method. Oh, now what is this? We can pass class also in the method. What do you mean by pass class in also in the method? What do you mean by that? Pass class. You pass parameters in the method, right? And those parameters can be of any type. It can be primitive type. It can be an object of any class. Yes, is an argument correct? Yes. No, sometimes okay. No, so the statement is not correct. The statement is not correct. If you are talking about the method parameters, employee is also a method. It's just that it happens to be a constructor. So suppose I take the setter method. So this name is an object of class string. I may create a method and have parameters. Those parameters, or you may call arguments or parameters. In any case, you can pass parameters of any type, right? It can be integer, it can be object of any class, isn't it? Isn't it? Anyway, don't get there. I think you're getting confused, so it's okay, right? So what I'm trying to now tell you is, and what am I explaining to you, that you have quite a few methods that are there in the superclass, and you may have a need to override it. For example, let's go back to the employee class, and you see m3.print details. You remember, see, print detail, print employee details, print employee details, m1.print employee details, m2.print employee details, and m3.print employee details. What it does, you know, when I run this application, it prints to me, you know, ID is whatever, name is whatever, and address is whatever. It prints to me, and this is the function that does the job, isn't it? Now what I'm going to do is, please see what I'm doing. I'll write system.out.println. I'll say m3. That's it. I'm just simply saying m3. You know what this println does? This println takes, actually, you know, it can take a string, it can take an object or whatever. It converts this to a string. So internally, it actually invokes a function called toString. So m3 dot, it is as good as writing m3.toString. So it's going to give me the string representation of it. And now when I execute this, please see this last line. It prints to me com.pwc.training.java.basics.employee and @ Now how does it convert this to a string? It actually converts this to a string with the help of a toString method, which is there in the object class. I did not write any method over here in the employee class which converts it to the string. I didn't do that. I didn't do that. I do not. I just have setter and getter methods. But then you know very well that employee extends from what? Come on, one word answer. Employee extends from what? The object class. And in the object class, you have got toString. And you see this in toString, what have they written? Get class.get name. So it gets the name of the class from year till year. This is the name of the class. It's a fully qualified name of the class. I repeat, it is the fully qualified name of the class. That means com.pwc.training.java.basics.employee. Along with the package, that's a fully qualified name. And then it has @ Can you see this @ here? And then it has got the hash code. Then it says integer.toHex string hash code. It converts the hash code to hexadecimal value. And that's how, this is the default logic of converting an object to a string, or giving you the string representation of a given object. And it just simply say hash code. Now what is this hash code? This hash code is again native. See, if I control click on this, it takes me to the function. But is the implementation here in Java? No, it's native. What does this mean? The implementation of hash code is written in their library file, in their native library, correct? And this calculates a unique code for each and every object. I repeat, it calculates the unique code, a unique number. It returns to you an int. Please see, it returns an int, a unique number. Two different objects will actually end up having two different hash codes, correct? So this is how it constructs toString. But I don't want that. I don't want that default toString representation of string in the default way. I wanted to override it. So see, this is my employee class. This is my employee class. Okay. So this is my employee class, my dear friends, and in the employee class I will now have another method called toString. I'll just type toString. See, I've just typed a toString. See my hands here. I've just typed toString, and the IDE is smart. It gives me the complete signature. I just hit the enter key now, and it says this IDE is too smart. I don't want you to take that up. So I'll say public, and I will say string. I will say toString, and then open and close bracket. I want you to type it out, friends. Please don't use that hotkey. And now whatever I return back from here, that will be the string representation of the object on which once again of the object on which I will invoke toString. Correct? So I will say now, I'll say return, I'll say yabba dabba do. Okay, sorry, yabba dabba do. Okay, so this is what this is the hard-coded value that I'm returning back from here. What does this mean? Now if I print system.out.println M3, what will it do? It will execute the toString method, the one that I have written in the employee class, because I am overriding. Can you see this? It is overridden. When I click on that, it takes me to the toString method of the super class. Overridden. You remember I talked about overriding yesterday also. My father has got a habit of saving. He has got a functionality saving. I will also certainly have saving. If I do not override, I will save exactly the way he saves. But if I override, the overridden method will be executed. Whatever is the functionality, my specific functionality of saving is there, whatever is written, I will execute. That will be executed. So similarly here, please see. So it is overridden. You can see that here, it's overridden. Now I'm going to go back here. Sorry. Okay. And then you see here, I'm going to print this. So what do you expect to see? What will be printed here? Will it execute the logic of toString of the super class, which happens to be object, or it will execute the logic of the employee class? I mean the toString method which is there in the employee class, the one that is there in the employee class. But the fun, see the fun here now. It was emp3, but when I say print me emp1, I say print me emp2. In all the cases, tell me what will it print? I need an answer. I'm saying print me M1, M2, M3, the string representation of M1, M2 and M3. What will it print? Tell me. In all the three cases, what will it print? Yeah, super. Yabba dabba do. Correct? Yeah, correct. Very nice. You all are good at typing it out, huh? Yabba dabba do. Good. It will exactly print yabba dabba do. Why? Because I have hard coded the value, which is meaningless. If my manager sees me something like this, he is going to kick. Okay, I won't say anything further. So you see this, so I'll say return. No, I won't say return here like this. Of course, I will have some meaningful logic. And I know that each employee, even if, don't you think it is possible that in your company, you have two employees with exactly the same name? Possible, right? I have a UX designer, in my team. Her name is Shivani Singh. And I also have someone from pre-sales. Her name is also exactly Shivani Singh. What a coincidence, it's in my own company. So you can very well have two people with the same name. You can have still two people, staying in the same place, address the same, but at least the ID of the employee will be certainly different. I repeat, the ID of the employee will be certainly different. I am the one. I written yabba dabba do. Did it give me any compilation error or any runtime error? Did it give me any compilation or the runtime error? Did it? No. So what was wrong? Was my Java code wrong? Was there a compilation error? Was there a runtime error? No. It's a logical error. It does not make sense. It is illogical that the string representation of two objects is exactly the same. Correct? Well, there can be. Two strings can be same, right? Two strings can be same. I'm saying employee as far as the business meaning and the business semantic. As far as the semantic of an employee class is concerned, you will never have two employees exactly the same. At least ID will be different. So what I'm going to do, I'll say return this dot ID. Correct? Return this dot ID dot toString. So if I want to convert this, of course I've got to return a string. I cannot return an integer. It is a string representation. So I'll say new string, or I'll just simply say string dot value of, and I'll say this dot ID. This also gives me a string. Correct. Now when I run my code, my employee app code, see this, I will get exactly the string representations 101, 102, 103. Here you go. Correct. Or if I want to be very specific, and in my application, if I want, whenever I want to print the employee object, it must print the entire state of the object. I'll say this dot name, and I'll say this dot address, or whatever way you want to construct the string representation. It is absolutely fine. Now whenever I want to print the entire state, you see this 101 Shakir Baroda, 102 Shazia Baroda, and 103 Motil Chennai. Isn't it? You got that? Tostring method. I have overridden the tostring method, and trust me, you will come across the need to do this many a times, many a places in your application. Come on friends, get started. I want you to implement the tostring method in your application. I am going to stop sharing the screen, and you must be able to do it all on your own. Yeah, tell me if you have any questions. Okay, sir, I did not understand the last part, the hard coding part. You can please explain the part again. Hard coding part means what? So you shouldn't be hard coding, isn't it? Now at this, now over here, have I hard coded the string representation of employee when I override it? No, I was hard coding earlier, which was not a good thing, right? I mean, how can every employee be yabadabadu? Isn't it? Each employee will have a different representation, isn't it? You as an employee at PwC is different as compared to another employee. Even if there are two people having the same name, at least the ID will be different. So the string representation of the employee object must include ID at least. What I have done is that I'm including ID, name and address, all the three. So this gives me, now I don't need string.value of. The reason is I am already concatenating it with string. So the moment you concatenate any data type with string, it automatically becomes a string in Java. So I'm returning this value, right? That's how it is. See, once again I run it and I get 101, 102, 102. You got that? Right? Start writing. I'm sure you're going to you're going to get that. No, I meant, how did we hard code is what I am asking. We hard coded it like this, isn't it? Earlier we hard coded it like this: return yaba taba do. This is called hard coding the value. So on any object you invoke m1, m2, m3. Now on any object you invoke this m1, m2, whether it is m1 or m2, hajar objects, it will still give you all the string representation of all the objects is exactly the same. Why? Because I hard coded the value. Hard code matlab literal dalna, right? That's how it is. So instead of that, they are not equal. So tell me, what is it that I must be using? Should I be using equal to, or I must use dot equals? Come on, what do you think? So suppose if I want to test system.out.println, I'll write, I wanted to test m1 is equal to m2. Is this the right way of doing it, or I must check the value by using m1 dot equals? Come on, what do you think? Equals. Very good. So I will say equals, and then I'll say m2. Correct? This is what I have done. But now friends, take a look at this. m1, m1 belongs to which class? Employee. And in employee class, do you see equals function here? Have I implemented the equals function here? No, I do not have equals function here at all. See, it's nowhere. See, why it is giving me still over here is because this is there from, okay, I'll remove this inherited member. See, there is nothing equals, you see, it's not there. But equals method is still there. Still I am able to use it. I am using it dot equals. What does this mean? Equals method is there in which class? Yes, exactly. Very nice. So your employee class, it extends from the object class. Correct? And in the object class, you do have the equals method. But this equal method also ends up doing what? It ends up checking the references. So this does not work with me. Right? This does not work with me. So what I need to do? I'm sorry. What I need to do? Tell me. Give me one word answer. What is it that I need to do? Override. Yes, exactly. Override which method? Which method do you think I must be overriding? I must override the equals method. So I will go towards the end of the file and I will override the equals method. Right now, again, this is very smart. It will do, accepts of classes parameter to equals. Okay, no, okay. I don't want to go by this. Okay, so I'll just cancel this out. Okay, so I will say public. All right, I'll say, so what does equal return to me? Tell me, what does equal return to me? True or false? It's a boolean. That's what we check for. So I'll say public boolean and I'll say equals. You see this? This is what I'm going to do. Equals. Right, but equals must take a parameter. Take a look. I go again back to my object class, and equals takes an object. That means the current object is equal to the object that you pass as a parameter or not. That's what we have done. So is emp1 equal to m2? M1 dot equals means you are comparing m1 and m2. So this m2 is passed as a parameter to the equals function. So I've got equals, and here I will take an object of which type? Since I'm overriding it, I can decide the object type. Of course, it is supposed to be the same type, and I say employee obj. That's how. And I have to return true or false. If I return false, always none of the objects, even if they are equal, it won't really result as. So of course, this is again hard coding. This is not what I'm going to do. So tell me, based on what do you think you will say that the two employee objects are equal? Based on what? Based on what? Based on the value of which property? Yes, super. No, not the reference, Manisha. Yes, correct. ID, isn't it? I did mention this, and you all understand this. It goes without saying. It is a no-brainer, right? That ID will certainly be different, isn't it? So if the two employee objects are same, that means the ID is same. If they are different, that means if the ID is different, that means the two objects are different. So I'm going to do what? I will say return. What will I do? What will I do? I'll say return. I'll write this dot id is equal to obj dot id. This is what I'm going to do. Now, why is this equal to okay? Because id is of what data type? Is it a reference or it is primitive? Tell me. It is int. It is primitive. So I can very well use equal to. In fact, I will have to use equal to only. I cannot use dot equals here at all. So this is just perfect. That means if the if the two objects, the one on which the method is invoked and the one that is passed as a parameter, if their IDs are equal, the objects are equal, or else they are not. So please see this now. This will give me false. Of course, this is false because emp1 has got 101 as the ID and emp2 has got 102. Let me check. See, this will return false to me. You can see this false. The two objects are not equal. But if suppose I create an object, I say employee emp4 is equal to, I'll say new employee, and this time I will say 101 is the ID, which practically will not be possible in business. I repeat, which practically will not be possible. If this is happening, you are supposed to throw an exception saying that you are trying to enter the ID of the employee which is already taken. Don't you think many a times you see it happens that you try to register on some website, some portal, you try to register and it says the username is already taken, isn't it? So here similarly, here also employee 101, and if I say the name is whatever the name is, new name, or it's a customer, or it's an employee that we are talking about. So for example, I'll say Deepak is the employee, comma, and I will say the address is Mumbai. Okay, here you go. And if I try to compare emp1 with emp4, tell me, should it return to me true or false? What should it return to me? It should return to me true. Correct. So now let's run this and see the results. It should return to me true, isn't it? And if it is, maybe I have not maybe, in fact, in this kind of a business, I will certainly have, you see this here, I'll say if emp1 dot equals, I'll say emp4, then in that case, I will say throw new runtime exception, the two employees cannot have same id. Okay, please see this, see what I'm doing now. When I run this, it will throw an exception. Why? Because id of emp1 and emp2 is same. See, exception, the two employees cannot have the same id. I have thrown an exception explicitly, deliberately. I mean, based on the logic, not deliberately, but based on the logic. This is just perfect. But if I change this to 104, the exception will not occur. Why? Because I am checking only if they are equal. Then there is a problem that violates the business rule. That violates the business rule. Again, I repeat, that violates the business rule, or else everything is just perfect. I'll say else. I'll write as out everything, or I'll just simply say validation succeeded. I'll say validation succeeded. So this will now give me validation succeeded. You see this, validation succeeded, isn't it? That's how it is. That's how it is. Okay, but if at all it is equal 101, if I say, then in that case it will throw an exception. Right, friends? Come on, I want you to take a look at this, see what have I done. I want you to implement. So going back to ClickUp here, implementing equals, implementing toString, or rather I will say override toString and override equals. Okay, this is what you are supposed to do. Get started, friends. Override the toString of employee class to print id, name and address. Override the equals function of employee class in employee class to test the equality based on the id of the employee. Okay, friends, come on, do this. So this is what you are supposed to do. Okay, here you go. I have put in the message window. Okay, furthermore, then let me explain this. See, no, still I'll explain this to you. See here. So this is the employee class that we have created, and we have overridden the toString function here. Okay, simple toString I wanted to convert. Similarly, you will find there is a class called string in Java, right? We have been working with the string class. Here, don't you think they have overridden the toString function? Take a look. See this toString function, and it says return this. The object which is already a string itself is returns the string itself. Now here they are returning this. They have not written any. They have not written any specific logic over here, and it internally does the job. String is a special class. Otherwise, let's go to integer and check it out. Integer, and let's see the toString function here. So here also see they have overridden the toString function, and there they have written some value. You can see, I mean, sorry, some logic. Here they have written some logic. You can see this is again, okay, this is static toString. Here it is. So you see this return toString, and this is the other function that they are calling. And yes, it's the same. Eventually, it is the same function that gets called, and they have written the logic of how to convert an integer to a string. So many a class you will see that you will have a need to convert it to a string so that you can have a string representation of that, of the object of that class. It is as simple as this. Got that? Yes. Equals is so out of toString and out of. Okay. So we have seen the toString function, we have seen the equals function, and also in the string class, you see how does it actually manage the equality of string. So you see this equals function here. Can you see this equals function here? And they have written the logic. Take a look. They have written the logic out here, equals function, they have written the logic. So they check character by character whether it is byte by byte, whether it is equal or not. And at all, if at all it finds that it is not equal, then it returns false. Or else if each and every one of those characters is matching, then in that case they return true. Take a look. Right? That's how it is. That's how it is. So they have written the logic. They have overridden the logic of the two of the equals function. Similarly, we have also overridden the logic of equals function in our class. So see, we have talked about a lot of things. We have talked about the state of an object based on the properties that you define in the class. We have talked about the behavior of the object based on the functions that you define in the class, toString and equals function as well. Very critical functions, friends, toString and equal, and hash code as well. But we will see that later if time permits. But then otherwise, you see this is what we have discussed. So I believe by now you are crystal clear that you, on the properties of the class, so that when you create objects of those class, see this, when you create object of the class, each one of those objects has got its own properties, and the values of those properties put together becomes the state of an object. So this is the state of one object, this is the state of another object, this is the state of yet another object, and this is the state of yet another fourth object, right? We have seen this in action. We did create a class from where in which we created objects of class employee, several objects in fact, and we did work on the equals and toString representation. Correct. Now furthermore, if at all I want to maintain the total number of employees in PwC, see my question. Okay, just a moment, friends. Okay, I'm sorry. So here, what if I want to maintain the total number of employees in PwC? So will the value of total number of employees, so if I ask you what are the total number of employees, do you all know how many employees are there in PwC worldwide? Can you put a number here? Or at least India, in India, how many employees of PwC? Any idea? Have they shared this in the induction program? 2,82,000, right? Okay, very good, perfect. So 2,80,000, 2 lakh plus. So this 2 lakh, this value, so you see if it is 2,80,000, so if I ask Gaurav is going to tell me 2 lakh. Oh, everyone is giving me a different number. So this example is not good to talk about static variables, because static variable, the value will not value can very well change, of course. It can very well change, but at least when I ask the employee of a company, they must all give me the same answer. It can change, but then everyone must give me the changed answer. So suppose today it is 2 lakhs, and then tomorrow if it is 2,02,000, then in that case all will tell me that yes, today we have got 2,02,000 employees. So okay, let's take a figure here, 2,84,000. So there are 2,84,000. So if I ask Deep, they will tell me, acha bas. theek hai. Okay, I have a better way of finding it out. So he is the CEO of your company, correct? The annual revenue is 43 billion. Total number of employees is 284,258. 2,84,258. Right? This is the total number. Okay. Right. So you see this here. So you see this. If I want to put this value here, so I'll say private. Okay. And I say int. All right. And I say total employees is equal to, and I put a value here. Okay. I put a value here. This is the value I have for total employees, isn't it? So now if I put this total employees, okay, why was the problem? Okay. there is no problem. Okay, so you see this when I say private int total employees is equal to whatever the value is. Now what will happen in this case? Now this is also an instance variable, ID, name, address. Like ID, name and address, you've got total employees. So what will happen here? Here you will have in your, right, I will take this a bit down. Okay, so here like you've got address, you will have yet another thing called what? Total employees. This is what you will get over here, right? You will have to, I mean, this is what you're going to put here, right? And then again you will have total employees here as well, and then again you will have total employees here as well, and then again you will have total employees here as well, isn't it? Come on, yes or no? Correct? So here, and you will have total employees here as well as here, and then you will have total employees here as well. But don't you think the value of 2,84,000 and whatever will be replicated here, because it's an instance variable, it's an object variable, and each and every object will have a copy of it. Each and every object will have a copy of total employees. Does that really make sense? Does that really make sense? It does not make sense at all. Why? Because the value, now note my words, see the statement that I'm making, the value of total employees can change. Of course, you may hire 2,000 more people tomorrow, and then this number will change, this figure will change, that's fine. But then whatever it changes to, it is the same value that remains static across all the instances of employee. I repeat, whatever value you want to put, that value will remain static across all the instances of employee. That means if you ask this object, it's going to say we have got 2,84,000. You ask this object is going to say 2,84,000. This object, you ask how many employees, it's going to say 2,84,000. And if at all you increase by say 2,000 more, so 2,86,000. So but then the moment it becomes 2,000 more and 2,86,000, now I ask any one of these employees, they are all going to say 2,86,000. Every one of you are going to say the same thing, 2,86,000. In such a case, it does not really make sense to create total employees here in each one of these objects. You remember we did talk about the permanent generation. You remember we did talk about object of class. So at the time of loading the class, I want a variable to be created out here, and there must be one single occurrence of that variable across all the objects of that class. For example, here in the permanent generation here, correct, there will be an object of class created. Needless to say, there will be an object of class created, and that object of class, see, it will be an object of what class? Correct. And this object of class will hold the bytecode information of the employee class when it loads the employee class, certainly. And at that point of time here, in this object of class which holds the bytecode information of the employee class, I repeat, this object of class which holds the bytecode information of the employee class will have yet another additional variable, one single occurrence over here called total employees. So I bring that over here, I just change the so that I can accommodate it over here. I'll say total employees. So the total employees will be, where will the total employees be? Total employees will be in the object of class of the employee class. Why will it be in the object of employee class for the employee class? Because this is where I'm declaring it in the employee class. Hence it will be in the object of class which holds the bytecode of the employee class. There you will have total employee when I make it static. The moment I make it static, there will not be multiple occurrences, one for each object of total employees. There will be one single occurrence here. Since it is a primitive type, the value also will be exactly here, right? The value will also be exactly here, is equal to is equal to, and then the value, whatever the value is, the value will also be here. So now whether you ask this employee object how many employees, it will pick up total employees from here. You ask this object how many employees, it will pick up from here, this object and this object and so on. So you see this here, I just scroll down out here, okay, and then I towards the end of it, I'll say, all right, now see the fun, I'll say I don't have to say this, I cannot say this is the reference to the object, come on, yes or no, this is the reference to the object, so I won't say this, I'll just simply say total employees, that's it. I'll just simply say total employees. If I say this dot, then in that case, you see it will refer to an object. You can very well do it, but it will refer to an object and it will be the same across all. So, but I don't need to do this at all. I don't need to do this at all. I'll just simply say total employees, and you see this total employees of is what? It's a static variable. Now I'm going to get the same value across. So please see this. Now when I run this code, okay, I will have to make this 104, and you see this, all the objects are getting the same value. You can see this here, all the objects. Did I assign value? Did I execute the setter method and set the value? Absolutely not. And did I, okay, you will say that Shakir, you initialized it over here. Okay, I won't initialize. I will just keep this as it is. So I'm going to get what? I'm going to get 0. You see this? I'm going to get 0, and I will initialize it here in the application itself. But in order to initialize it, of course, I'm just for the time being making it public, though you must not make it public. You can have a setter method for this, also a static method. We'll come to that in a moment. Public, static, you see this? So I go back here, and once and for all, right on the top, I will say employee dot, I'll say total employees is equal to, what was that? Okay, 2,84,000. I'll just keep it simple now. And then each one of these objects will get the same value. Please see, did I set the values of different, did I set the value for each one of those objects? No. But for ID, name and address, I did set different values. I did set the value, and each one of those will get different values. But here I did not set the value on the object. I set total employees. But how am I referring to total employees? With the name of the class. Why? Because it is static variable. If I don't make it static, then in that case this will complain. You can see this will complain. It says that you are referring, non-static field cannot be referenced from a static context. You see this is the static context. So I go back here, and of course I want that to be static, and here you see it works like a charm. See this? Correct. Now one final point here with respect to static. So I have I will suppose I make this as private. Now if I make this as private, I will not be able to change it directly, and you see this again, this gives me a compilation error. It says you are trying to access the private, you see private access. So I decide, okay, let me create a setter. Now this kind of a setter is a static setter. Like I say public, try and understand. If I say void, and if I say set total employees, but this is fine, this function is okay, good. But then if I say this dot total employees, you see this, it's not giving me at all, but still, somehow I say total employees, I bring it over here, I say total employees is equal to whatever is the value that is passed as parameter int total emps, I'll say, so I'll say is total emps, like this. Okay, see this is what I've given over here. So it will help me, it will allow me to set the value itself. This will allow me to set the value, correct? But then you know what, you will be able to invoke this method on every object, because this becomes the object method. Instead I will say public static void. Public static void. What does this mean now? I will be able to invoke this method on the class directly. I repeat, I will be able to invoke this method on the class directly. I don't need to create an object at all. So I just go back over here and I say set total employees. You see this, I'm invoking not on the object. Friends, please note, see the difference between the object variable and the object methods, and the static variable and the static method. Did I invoke it on any one of those objects that I created over here? No, once and for all. So where is this value going to get stored? It is this place. Once and for all the value is going to get stored. So whenever I say employee class dot total employees, it is going to pick up the value from here. And even if you ask the object what are the total employees, it is going to pick up the value from here itself. So you ask any one of these objects, it's going to return the same value. Please see this. Run this once again. I've set the value over here. All the objects, you can see this, they refer to the same 2,84,000. You got that? Right? That's how it is. Now what I want you all to do is that, see this, static variables and methods. Okay, in employee class create total employees as static, create a static method to set the value, use this method to set the value from employee app, and include total customers, total employees in the toString method. Okay, come on, let's do this. This is what you're supposed to do. Okay, I've just pasted this, copied and pasted the assignment that you're supposed to do. Come on friends, please get started. Right, let's move on to the next stuff. Okay, I will now also static, I'll say variables and static methods. Okay, I have pushed the code, as you can see, so later on you can very well take the pull. Right, so we have static methods. Now you see this, you know very well that whenever a new object is created, the constructor will be executed. So tell me, as per this code where I am creating emp1, then I'm creating emp2 second object, I'm creating emp3 the third object, and then I'm creating emp4 the fourth object. So tell me how many times the constructor will execute. How many times the constructor will execute? Yes, 4 times. One for each object. So the moment an object is created, perfect. So the moment an object is created, the constructor is it does get executed. What if I want to write some code? What if I want to write some code which must be executed whenever the first time, once and for all, when the class is loaded? I repeat, once and for all, when the class is loaded. We have discussed this several times, my dear friends, that the class will be loaded once and for all. It will not keep on reloading the class again and again. So you see this, if I want that to happen, then in that case, I will just say static open and close bracket. This is known as static block. What is this known as? Static block. What does that mean? This will be executed the very first time the class is loaded. Okay, I'll write system.out.println once and for all when the class is loaded. Okay, this will execute. This will execute once and for all when the class is loaded. Take a look. I'll go to employee app and then I run this. You see this? How many times did this get executed? Only once. And see here, all the objects were created of the class after that. Why? Because of course, needless to say, we did discuss this several times and we did emphasize on the point that first the class is loaded and only then the objects of that class is created. So you see this, the class gets loaded and the static initializer. This is called static block, or you can also call it static initializer, because you can very well initialize the value of static variables from here. Okay, but one important point, you have a static function here. Say for example, we did create this static set employees. Now if I refer to, suppose something like this, I say as out, and if I try to refer to this.id, will it allow? Will it allow? It will not allow. Why? Because from the static method I cannot access instance variables. Otherwise, how will it know? How will it know that which particular instance it is supposed to refer to? Because this function will be called on the class, not the instance. Take a look. This function can be called on the class, not the instance. So if you end up calling this method on the class, how will it know that this refers to which particular object? So you cannot use right, you cannot refer to instance variables from the static method. Okay, you cannot refer to the instance variables from the static method, right? That's how it is. So this is all about, you know, static variable and the static methods and instance variables, instance methods and stuff. This is what we have learned. Now few more interesting things. You see this, I can very well mark a class as final. What does this mean? If I mark a class as final, if I say public final class, suppose if I say public final class, I will not be able to inherit this class at all. I will not be able to inherit this class. You see this? If I say I want to create a new class and I'll say that class is, say, contract employee, for example, and if I try to extend this from extends and I'll say employee class, it will not allow me to do so. You see, it very clearly tells me that cannot inherit from final employee class. So what do you mean by final along with the class? It means that you cannot inherit that class. Now it gives no error because it's not final. Then there are final variables. So if I say final out here, I will not be able to. Now here itself it is giving me an error. Why? Because if I say final, you know, sorry, I can do this. Okay, I say final int id, but then here it tells me, well, if it is final, you have to initialize the value of this variable because you will not be able to change the value of this variable. Final means what? It's kind of a constant. You will not be able to change the value of that variable. Correct? And you see this here in the setter method also. You can see this in the setter method here. It gives an error. It says that how can you change the value of final? Cannot assign a value to final variable id. So what I'm going to do here is I will just simply say equal to 101. And now no worries, no problem. But then of course, wherever I'm setting the value in the constructor and the other places, you see in the constructor also, see in this constructor also, it will complain saying that you said it's a final variable, it's a final value, then how come you are changing the value of it, right? But then if at all you change the value of the variable, I mean you could assign the value of the variable. That's what final is. You will not be able to change the value of the variable once assigned. So you see this, and I'm not going to make this final because it doesn't make sense to have final variable, the final value of employee. Well, it may make sense that once the employee object is created with a particular ID, you must not be able to change it. Right? Then in that case, if this is the case, if this is what you are doing, then in that case you will not be able to work with a default constructor. You will have to have a constructor with at least one parameter taking the value of ID. So forget about that. That's not important. But remember that final variables, the value of final variables cannot be changed. Going back to the setter methods, I will just, you see, no errors at all here. Correct? You can also have final variables within the function. So if I have a function here, any function, I can say final int I is equal to, I can say 5. But then if I say I is equal to 10, it will not take it. It will give me an error. You see this? There is an error here. Why? Because I said that int is final. So what are final variables? The value of which cannot be changed. What are final classes? The value of which cannot be, the class cannot be inherited. You can also make a particular function as final. What does that mean? That particular function cannot be overridden. The moment you make a particular function as final, you cannot override that function. Okay, I want you to play with this final keyword as I have explained it to you. Just play with it in your code. Use final and see the error message that you get. Do see the error message. That's what it is. You will be able to learn a lot while reading the error message. So please use final here, see what are the error messages you get, use final here and then try to inherit a class from that class and see the error message that you get. Use final and try to change the value of the variable and see the error message that you get. Okay friends, play with it. I'm going to give you what's the time? Okay, it's 4:16 already. I will give you all 10 minutes to play with this and then I will give you all 15 minutes of tea break. So it's almost 25 minutes is what you have got on your hand. Okay, play with this, take a tea break, relax, and then we come back and then continue. So we will continue from It's almost 4:17 now. So just assume 4:20. So 10 and 15. So 30, 4:45. We will resume back at 4:45, friends. Okay, we will resume back at 4:45. Right, so I hope you all can all see my screen. If not, just a minute. So can you all see my screen now, friends? Please confirm. You can see my screen. All of you all there with me? Come on, last few minutes for the day. Last few minutes. Last few minutes. Please see this now. What I'm going to do here is I'm going to explain to you. There's something like interface. So when you have, when you have got. Right, so you see we talked about creating a class and then we talked about creating two subclasses. So this is the lineage, right? This is the hierarchy of classes. And whenever you have some default behavior, some generic behavior to implement, you implement that in the superclass, whereas some specialized behavior needs to be implemented, that can be implemented in the subclasses, right? That's how it is. But then many a times you would want a class to play a role. I repeat, you would want a class to play a role, or you would want a class to sign a contract saying that whatever functionality is declared on the contract, I will certainly fulfill that functionality. So in such a case, what you end up actually creating is an interface, right? This is how in UML the interface looks like. So you see this, I can create this or maybe this, there are various different ways of creating an interface. This is yet another icon that can be used in order to create an interface, right? But then otherwise, you see, you can have an interface created. You can have an interface created and okay, let me do one thing. I will once again go to UML. Here you are, and then you do have an option over here for the interfaces, right? This is how it is, provided interface and something like that. Okay, correct. Okay, leave it. So I will create just simply something like this. I will say tax calculator, for example. Tax calculator is an interface and it has a function called calculate tax. All right, calculate tax. Suppose this is the name of that function which is declared here. Now you know what, the way interfaces behave and the way interfaces are used has changed a lot from 1.8 onwards. So if you create an interface in your application, you can very well have a class implementing that interface. It's not extend, you will implement the interface. So you can very well have a class implementing some interface. So for example, you have a class called invoice that implements tax calculator. So suppose you have an invoice, okay, some kind of a class here. Oops. Some kind of a class here called invoice class, and that invoice class implements the tax calculator. So suppose I say this implements tax calculator. Okay, and for the implements there is a special relationship that is used in order to show or denote the implementation, so I will use one of those. Here it is, implementation. You see this here? So this is how the implementation is shown. There is a difference. You see, this is a dotted arrow, whereas this is a solid arrow. You can see there is a difference. Correct? So you have right. So you see this, a class implements the interface. Now if I have to write exactly the same thing here in my Java, then in that case, you see, I will create another package here. I will give the name of the package as, I'll say Java dot, I'll say interfaces. Okay, that's the package, and in that I create a class. I will give the name of the class as invoice. This is the class, but the name of the interface would be, I'll say interface, or else I can just create a class here and then I can select interface from here, and then I will say tax calculator. When I do this, I can keep on declaring the functions here. I repeat, I can very well go ahead and declare a function here. And please note, this is anyways, you don't even need to specify, you don't need to say that this is an abstract interface. You don't need to do it. See, it is not necessary at all. Why? Because it is redundant. You see, it is redundant. It is not needed because interfaces are anyways abstract. You never ever create instances of an interface, and you can declare functions here. So I can go back to invoice, and what will I write here? I will not write extends. Instead, I will write implements tax calculator. That's what I'm going to do. Now, when I go back to tax calculator, I can have a function declared here called public void calculate tax. You can see this. I can very well say calculate tax. Now, the moment I do this calculate tax, it is mandatory for me to in a class, whichever class implements that interface, in that class, I will have to implement the functions that are declared here on tax calculator. So I will have to say public void, I'll say calculate tax. You see this? This is what I'm going to do. You got that? Public void calculate tax. So this is the implementation. Now everything compiles successfully. I can have several classes implementing the same interface. I can have several classes. Suppose, say for example, if this is a class which is an export invoice, so I will just change the name of it. You can always change the name by using function shift F6, and you can say invoice, and I will say export invoice. Right, so you see the name of the class has changed and everything has changed. Now I will create another class and I will say local invoice. Okay, I'll say local invoice, or say rather I will say import invoice. Two different types of invoices. So this import invoice can also very well implement. So there can be n number of classes that can implement an interface, and what that interface is, in my case, it's tax calculator. Needless to say that the moment you declare a class and say it implements an interface, you will have to provide the implementation of all the functions that are declared on top of that interface. So I will say calculate tax. You can see this calculate tax here. Correct. That's how. So here when I write as out, I'll say calculating tax for import invoice. And here I will say export invoice. Here I will say S out calculating tax for export invoice. Now, when do you think you will be creating so you could have also created tax calculator as an abstract class and then declared this function as an abstract function. Am I right? You could have done that very well, isn't it, friends? Come on, yes or no? You could have done that. I could have created an abstract class and then extended from that abstract class, and then I could have, yes, isn't it? Yes, very correct. But there is a big difference. There is a huge difference. Correct. We could have done that, but there is a huge difference. What is the difference? In an interface, the variables that you define are always final. So in an interface, if I have to define a variable, I cannot consider that variable to be an instance variable for export and import invoice. What does that mean? If I create an object of class export invoice, if I create an object of class import invoice, both will have exactly the same value of the variable that I define over here. So for example, if I say int, like for example, if I say int default tax, okay, is equal to, if I say 25, right, or I don't say anything over here, right, I say 25, and then you see this, it gives me an error. It says might not have been initialized. So I have to initialize the value of that variable. And if I say 25 over here, so it is, now I don't even have to say final, it is by default final. Even if I don't, see, when I move my mouse pointer here, it says it is redundant. Modifier final is redundant. What does that mean? Redundant means it's not needed. Double hai. I mean, you are doing it unnecessarily. It's redundant. You don't need to say it is final because it is anyways final. It is anyways final. And when it is final, if it is 25, the object that I create of import invoice and the object that I create of export invoice, both will have the same value of the default text 25. Well, if you really wanted that, then fine. But you cannot say that these are instance variables. As in case of customer class, this is a class. I can have ID, name, address. So in the super class itself, I can define properties, and those properties will be inherited in export customer and the local customer, and each object of export customer will have its own ID. Each object of export customer will have its own name. Each object of class local customer will have its own ID and name. So you see here you can have instance variables, whereas here you cannot have instance variables at all. In fact, if you define a variable, it is supposed to be final. That's one big difference, and that's the difference from programming point of view. But then otherwise, from design perspective, tax calculator or wait, I'm saying tax calculator because that's what I created, but interfaces as such, they define the contract. I repeat, they define the contract, they define the role that the classes would play. And in case of classes, here you see export customer can extend from customer class, it cannot extend from any other class. I cannot say comma and it extends from something else. But in case of interfaces, I can implement multiple interfaces. I can also implement a runnable interface here, for example, and yes, I will have to implement the run method also. Then in that case, see, everything compiles successfully. So one particular class can play multiple roles. You see, you are correct. See, you are, in your family, you are playing the role of a son with respect to your parents, but you are playing the role of an employee with respect to PwC. Right, friends? You're getting the point? Right? All of you are getting the point? You are playing the role of son with respect to your parents, but in company you are the same person, you are the same object, but you are playing the role of an employee. And in some other case, maybe you play the role of something else. If you are a part of some cricket team, you are playing the role of a batsman, or you are playing the role of a bowler. So that's how it is. One single class can implement multiple roles, but then one single class can belong to only one single hierarchy. You belong to the hierarchy of your family. There is a lineage, right? You belong to some family, and that's what it is. You cannot belong to multiple families. You can play multiple roles, and based on the contracts that you have signed with the others. You have signed a contract with PwC. Okay, I am going to play the role of an employee. You tell PwC, I'm going to play the role of an employee. So you are playing that role. And definitely, if you sign a contract with PwC saying that I will play the role of an employee, you will have to fulfill all the responsibilities of an employee. You will have to implement, not my words, you will have to implement all the functionality that is expected out of PwC. That's how it is. Correct. So a class can implement multiple roles, it can implement multiple interfaces, but it will belong to one single hierarchy. In case of a class, you can have instance variables declared on the superclass, and those are inherited, and each and every instance will have its own copy of those variables. In case of an object that is created of a class that implements an interface, the variables that are defined are in fact final. So each and every object will end up having the same value, and you cannot even change the value. So wherever you need to use a class, you will use an abstract class. Wherever you need to use an interface, you will use an interface. So whatever I have explained to you. Okay, Rakesh has a question. So sir, if we cannot create an object to interfaces, how can we access the instance variables declared in it? Yes, you can access it, but then the value of that will always be the same. You cannot create an object of interface, but can't you create an object of a class that implements the interface? For example, export invoice. Okay, so here I'll say I have a class, and I'll give the name of the class as invoice app. And in this invoice app class, I'll say main function. And in the main function, I'll say export invoice. Invoice is equal to, I'll write export invoice is equal to new export invoice. And then can't I write export invoice dot calculate tax? You can see this here. Can't I do that? Isn't it? And then I'll say export invoice dot, what was the name of that variable that I had given? Okay, the default tax, isn't it? The default tax. Okay, I'll say default. Okay, and then you see this default tax is equal to 25. You can see this here, but I have to, I'll say s out. I cannot assign the value. I will be able to get the value, but I will not be able to assign the value. Why? Because it is final. I cannot change the value. Is equal to, if I say something else, it doesn't allow me to. Why? Because this is final, right? You know very well what final is. I cannot change the value at all. So whether I create an object of export invoice or the import invoice or whatever class I create, one object, 100 objects, I will have the same value of that. Well, I am telling you these are, what I'm sharing with you is this programmatic difference and conceptual difference also. But towards the start of your career, you will never be expected to design an application saying, okay, you sit and decide what will be your what will be your which particular thing will be an interface, which will be a class. No, you will be using the classes and interfaces that are provided by Java library. You will be using the classes and interfaces that are already designed in your application, but you must know the difference between the two, and you must know that one is an interface and the other is an abstract class. Right, that's how it is. But at this point of time, if you have a question, how will I decide when do I create an abstract class and when do I create an interface? That will take a bit of a time. Not that it's difficult or something, but it is just that you need to get into the design mode and you need to understand, oh, okay, this must be an interface. It doesn't make sense to create a class over here, an abstract class here. It must be an interface, and I will create class implementing that interface, or I will have an abstract class, I will have a class extending from that class. It will take a bit of a time, but then at least from programmatic point of view, these are the differences which you must keep in mind. Can you reiterate the situation where we use abstract class and where? So that's exactly, Gaurav. So when you have a class that belongs to a particular hierarchy, which belongs to a lineage, when you want generalization and specialization, when you want to maintain the state of an object, and when you want to define the properties, you can see that here in the customer class we defined these two properties, and each and every object of the class that inherits from this class, each and every object of a class that inherits from this class will have its own copy of ID and name. This is not the case with an interface. In case of an interface, you cannot define variables assuming them to be instance variables of the classes that will implement this interface. That doesn't make sense at all. So that's the major difference, and the difference here is of conceptual difference also. Right, abstract classes, they define the lineage, whereas the interfaces, they define they define the contract, they define the role that a particular class would play. What is the other difference? One class cannot inherit from the other classes. So if it's an abstract class, this is an abstract class, and if I have a class extending from that abstract class, I cannot extend that from other classes. I cannot extend this from more than one class, but can I implement more than one interfaces? I can very well implement more than one interfaces. I hope you got that, right? Correct? That's how it is. So you see this, yeah. Okay, perfect, cool. So you see this is how it is. Okay, this is how it is, right? Perfect. Right, so we will stop here, and you can spend some time, half an hour, 1 hour, 2 hours, whatever you want. You have your cloud labs with you, play with this. I am going to push this code right away, and you will find this additional package called interfaces and whatever I have done over here, and you see invoice app and stuff. And then if I run this code, yes, it will run successfully. You see this, I'm getting calculating tax per input. And don't focus so much on the variables that you define here as final variables. Don't worry about that. Don't worry about this. We rarely do this. We do this, not a problem at all, but we rarely do this. And don't get too much don't get confused at all with these variables and stuff. What is important is that you declare functions on the interface and you implement those functions in the class that implements that interface, right? So see, calculating tax for export invoice, isn't it? And if suppose this is instead of export invoice, I say this is not an export invoice, this is a local invoice, or rather import invoice, then in that case here also, of course, I'll say import invoice, and then you see what executes is calculating tax for import invoice. Correct? So let me push this code, and I'll put a new comment, interfaces. Okay, and then you can take the pull, do some good learning work, R&D, and we will revisit interfaces. I've just given you an overview. We will revisit interfaces. There is a lot to discuss in interfaces. We will certainly continue with this. We have not yet completed our interfaces stuff. We will certainly continue. And what is it that we will continue? Right, new features added to interfaces in Java 1.8. Right, friends, from Java 1.8 onwards. Okay, friends, you got this? I hope you're getting this. Come on, I have pushed the code. Once again, I will push the code. I have put some comments. So we are calling it a day, friends. We are calling it a day. We will continue tomorrow in the morning. But I want you all to spend at least 1 to 2 hours on interfaces today. Play with interfaces, create different interfaces, create classes, implement interfaces, declare functions on that interfaces, and just simply implement those functions. Create objects of classes that implements that interface and invoke the methods, right? Try doing that. Do some Google work, do some research work on interfaces, and that way, okay, if not 2 hours, at least half an hour. Right, friends? At least half an hour. Okay, good, cool. Chalo, we will call it a day. See you all tomorrow at 9:30. Thank you so much. Have a wonderful evening ahead. Thank you. Thank you so much. Thanks. Thank you.